Dear students, Assalamu alaikum. Topic of our today discussion is Robinson annulation reaction. It is a carbon-carbon double bond formation reaction. Dear students, I am Dr Riaz and it is our 12th lecture from the course Advanced Name Reaction. Robinson annulation reaction. Robinson annulation reaction is a carbon-carbon double bond formation reaction. In this reaction, two fragments coupled with each other and gives a carbon-carbon double bond. In this reaction, a ketone, which is mostly the cyclic ketone, and the ketone may be the acyclic, but mostly the cyclic ketone, react with alpha beta unsaturated ketone to give a substituted cyclohexanone derivative. This reaction is called Robinson annulation reaction. What happened in the Robinson annulation reaction? A cyclic or acyclic ketone react with alpha beta unsaturated ketone to give a cyclic system. The product must be the cyclic system and it must contain the cyclohexanone ring. This reaction is called Robinson annulation reaction. This reaction is acid or base catalyzed, but predominantly the reaction is conducted under basic conditions. This reaction consists of three steps. It means there are three sub-reactions of Robinson annulation reaction. Which three sub-reactions occur in the Robinson annulation reaction? Among those sub-reactions, one sub-reaction is Michael addition, the other sub-reaction is intramolecular aldol reaction, and the third is dehydration reaction. These three reactions occur within the Robinson annulation reaction. The first reaction is the Michael addition. It means enolate or the enol will be added to the alpha beta unsaturated carbonyl compound. As a result, a 1,5 dicarbonyl compound is formed. After the Michael addition, the other step which occurs within the molecule in the presence of a base is a intramolecular aldol reaction. In this reaction, one part of the molecule is converted to the enolate and then added to the other carbonyl compound to form a hydroxycarbonyl compound. That hydroxycarbonyl compound is called aldol because a single molecule contains two functional groups. One functional group is the hydroxyl group and the other functional group is the carbonyl group. After intramolecular aldol reaction, the third step is the dehydration. In this step, a water molecule leaves and gives a alpha beta unsaturated carbonyl system. That must be cyclic one in the Robinson annulation reaction. That cyclic system will be the cyclohexenone system. Reactants of Robinson annulation reaction. See what the term annulation means. Annulation means building a ring. It means a ring is formed during Robinson annulation reaction. It's clear that a ring will be formed. That ring will be the cyclohexenone ring. The ring must be the cyclohexenone ring. A bicyclic system containing a substituted cyclohexenone ring. If we use cyclic ketone as a reactant, then the product must be the bicyclic system and one cyclic system must be the cyclohexenone ring. See, reactant. One of the reactant of Robinson annulation reaction is the cyclic or acyclic ketone. It is treated with alpha beta unsaturated ketone in the presence of acid or a base, then it gives us enones. Here is a bicyclic enone. When we have a bicyclic product, if the reaction is started with cyclic ketone, then the product must be the bicyclic one. If the reaction is started with acyclic ketone, then the product will contain single ring. That will be the cyclohexenone ring system. So remember, if our reactant contain a cyclic system, then the product contain bicyclic system. If our reactant, that is the cyclic ketone and the other one is the alpha beta unsaturated ketone, if these are acyclic one, then the product will contain a single ring, that must be the cyclohexenone ring. Bicyclic systems are important systems, and these bicyclic systems are a part of various natural products. For example, these bicyclic systems present within the steroids. Robinson annulation reaction. This reaction was discovered by R. Robinson and W. S. Rapson in 1935. They were preparing a substances related to the sterols when they found that the sodium enolate of cyclohexenone reacted with various acyclic and cyclic alpha beta unsaturated ketones to afford substituted cyclohexenone. R. Robinson and W. S. Rapson was preparing sterol type systems. During the preparation of sterol type systems, they found that when sodium enolate of cyclohexenone, see, one of the reactant is cyclohexenone, a cyclic ketone. If it treated with acyclic or cyclic unsaturated ketone, then they afford a substituted cyclohexenone system. After this, Robinson recognized the generality of this transformation, which was quickly adopted by the synthetic community, and today it is widely used in the synthesis of complex natural products. Definition of Robinson annulation reaction. The reaction of a ketone that may be the cyclic or may be the acyclic, but most often it is a cyclic one. The reaction of a ketone with alpha beta unsaturated ketone to give a substituted cyclohexenone derivative in the presence of acid or a base, then the reaction is called Robinson annulation reaction. See, the reactant of Robinson annulation reactions are the two ketones. One is the simple ketone, that may be the cyclic ketone or the acyclic ketone, and the other ketone is alpha beta unsaturated ketone. Remember, alpha beta unsaturated ketone must act as acceptor, must be the electrophilic species. So, and which center of the alpha beta unsaturated ketone act as electrophilic center? Remember, that is the beta carbon. Beta sp2 hybridized carbon of alpha beta unsaturated ketone will act as electrophilic center. So, the ketone, the first ketone, which is the simple ketone, that may be the cyclic or acyclic, will be converted to enolate. The enolate of a ketone act as a nucleophilic species. Then this enolate attacks at the beta carbon of alpha beta unsaturated ketone to afford a 1,5 dicarbonyl system. So, the addition of the enolate of a ketone to alpha beta unsaturated ketone is called Michael addition reaction. Remember, Michael addition reaction is the reaction of addition of enolate of a ketone to alpha beta unsaturated carbonyl compound. If this reaction is acid or base catalyzed, then this reaction affords a cyclohexenone derivative system, and this reaction is called Robinson annulation reaction. General features of Robinson annulation reactions. General features of the reaction are: first one, it is a combination of three reactions. It means three reactions. We can say there are three sub-reactions which occur within a Robinson annulation reaction. Among these three reactions, one is Michael addition. Remember, in the previous slide I told you that addition of enolate to alpha beta unsaturated carbonyl compound is called Michael addition. The second reaction which occur in Robinson annulation is intramolecular aldol reaction. In this reaction, aldol is formed, and the third reaction which occur as a sub-reaction in Robinson annulation reaction is the dehydration reaction. Robinson annulation reaction is acid or a base catalyzed, but predominantly the reaction is conducted under basic conditions. The reactant of the reactions may be the acyclic enones and the cyclic ketones. If acyclic enones react with cyclic ketone, then it affords bicyclic systems, whereas cyclic enones and cyclic ketones gave rise to polycyclic fused enones. Remember, there are two reactants of the Robinson annulation reaction. One is simple ketone and the other reactant is alpha beta unsaturated ketone. If one of the reactant among the two reactants of Robinson annulation reaction is the cyclic one, then the product will consist of a bicyclic system. One of the bicyclic system must be the cyclohexenone system. If both of the reactants are the cyclic one, I mean simple ketone is also the cyclic one and alpha beta unsaturated ketone is also the cyclic one, then the product will consist of a polycyclic fused system. But among these polycyclic fused system, one cyclic ring must be the cyclohexenone ring. Methyl vinyl ketone and its various derivatives are used most often as the enone component. It can be conducted as a one-part process, but yields tend to be higher when the Michael adduct is isolated and then subjected to the Aldol reaction. See, this is a very important point. It can be conducted as a one-part process. I mean, all the three steps can be completed in a single part, but yield will be the low. If we divide the steps in a separate part, I mean, the first step is the Michael addition and we isolate the Michael adduct, Michael product, and then subject it to intramolecular aldol condensation, intramolecular aldol reaction, then the yield of the product will become higher. If this reaction in a single part, then the yield of the product will be low. And if we isolate Michael adduct and then subject it into intramolecular aldol reaction in a separate step, then the yield of the product will increase. Alkylation of unsymmetrical ketone occurs regioselectively at the most substituted alpha position unless severe steric interference dictates. During the aldol reaction, the Michael product obtained after the Michael addition is a 1,5-dicarbonyl system. So, when the 1,5-dicarbonyl system is subjected to aldol reaction, then one of the carbonyl group is converted to enolate. So, it's a question that the Michael product contains two carbonyl group. So, which of the carbonyl group will be converted to the enolate? So, the answer is that the most substituted alkylation of unsymmetrical ketone occurs regioselectively, and alkylation occur at the most substituted alpha position unless severe steric interference dictates. So, I am telling you that which carbonyl compound, the Michael adduct contain two carbonyl group within a molecule and it is a 1,5-dicarbonyl system. Then when this Michael adduct is subjected to aldol reaction, then first of all one carbonyl will be converted to the enolate. So the question is, which carbonyl from the dicarbonyl system is converted to the enolate one? Remember, that must be the less hindered carbonyl group. The less hindered carbonyl group will be converted to the enolate and then it attacks at the more substituted carbonyl group to afford a aldol product. It is a regioselective cyclization and it can also be achieved by using preformed enolates or enamines under non-equilibrium conditions. We were discussing general features of Robinson annulation reaction. The annulation reaction generates 5 stereocenters within the product. But when that product is subjected to dehydration, 2 of the stereocenters are lost and the product have 3 chiral centers. The stereochemistry of the product is dependent on the reaction conditions. The enantioselective variant, this is a very important point, enantioselective variant of Robinson annulation reaction is known as Hejaz-Parrish reaction because enantioselective variant of Robinson annulation reaction is discovered by Hejaz and Parrish. That's why the enantioselective variant is known as Hejaz-Parrish reaction. Here is a general reaction. which showing the Robinson annulation. Sodium amide is a base, solvent is diethyl ether. The reaction occurs at 0 degree centigrade. One of the reactant is cyclohexanone, simple ketone, and the other coupling partner, the other reactant is alpha beta unsaturated ketone. This is alpha beta carbon which contain a pi bond, alpha beta unsaturated ketone. This alpha beta unsaturated ketone act as electrophile. It's Michael acceptor. This is Michael acceptor. This is simple ketone. This will be converted to the enolate in the presence of base, and the enolate of this cyclohexanone will act as Michael donor. When a Michael donor is added across the pi bond of the alpha beta unsaturated carbonyl compound or the Michael acceptor, then it affords a 1,5-dicarbonyl compound which will subjected to intramolecular aldol condensation reaction and then dehydration reaction. After the dehydration reaction, it gives this cyclohexanone ring system. See this one. It contains a black colored pi bond, black colored single bond, and the red colored single bond. This red colored component came from alpha beta unsaturated carbonyl compound, that is a Michael acceptor, and these are the new bonds. Black bond are the newly formed bond between the two reactant. One reactant is cyclohexanone, the other reactant is alpha beta unsaturated ketone. The cyclohexanone is shown in a blue color and conjugated ketone is shown, conjugated ketone or the Michael acceptor is shown with the red color. Between these two components, a black colored bond are the newly formed bond between the two coupling partner. So this reaction was discovered by Robinson and Rapson in 1935. See this one. This is the sodium enolate of cyclohexanone. The reactant is a cyclic ketone. It means the cyclic ketone is converted to the enolate, sodium enolate. It's a cyclic component. The alpha beta unsaturated, which is a Michael acceptor, it's also the cyclic component. Then the product, see the product. The product contains a 3-cyclic system. The central cyclic system is the cyclohexanone ring. So remember, one of the cyclic ring which will be formed during Robinson annulation reaction is the cyclohexanone ring. So the product of the Robinson annulation reaction must contain the cyclohexanone ring. Ether, diethyl ether is used as a solvent and acid workup. Then when the sodium enolate of cyclohexanone react with alpha beta unsaturated ketone, then it gives us polycyclic fused enone system. This reaction is the modification of Robinson and Rapson reaction, which was discovered in 1935. So this is the Robinson annulation reaction. See the ketone, which is acyclic one, Michael donor. This is alpha beta unsaturated ketone. It's a Michael acceptor. This is also the acyclic one. Here the two coupling partners of Robinson annulation reaction, the two reactant of Robinson annulation reaction are acyclic systems. When the reaction is acid catalyzed or the base catalyzed, the first step is the Michael addition and it gives us 1,5-dicarbonyl compound. See this one. This carbonyl compound is at position 1, 2, 3, 4 and 5. So here we are saying that product of Michael addition reaction is 1,5-dicarbonyl compound because the relationship between two carbonyl compound is a 1,5 relationship. This 1,5 dicarbonyl compound is subjected to intramolecular Aldol reaction. So this is intramolecular Aldol reaction. This is not the intra, because both reacting partners present within the same molecule. After Aldol reaction, it gives us beta hydroxyketone. See this one. Hydroxyl group is present at beta carbon of the with respect to the carbonyl carbon. This is alpha carbon and this is beta carbon. The product of Aldol reaction is beta hydroxyketone. Beta hydroxyketone is subjected to dehydration step. Water is lost. Hydrogen from the alpha carbon and OH from the beta carbon is lost and gives a double bond. So it gives a cyclohexenone system, that is substituted 2-cyclohexenone. So mechanism of Robinson annulation reaction consists of 3 steps. The first step is the Michael addition of the enol or enolate across the double bond of alpha beta unsaturated ketone, and the product of Michael addition reaction will be the 1,5-diketone. 1,5-diketone is also called Michael adduct. Formation of Michael adduct followed by an intramolecular Aldol reaction. So the next step of Robinson annulation reaction is intramolecular Aldol reaction. As a result of intramolecular Aldol reaction, a beta hydroxyketone or the keto alcohol is formed. So the product of intramolecular Aldol reaction is a keto alcohol. Finally, a base catalyzed step, that is the dehydration step. In this step, beta hydroxyketone is dehydrated and gives us substituted cyclohexenone. Mechanism of each step is discussed separately in the next slides. Stepwise mechanism. First step of Robinson annulation reaction is a Michael addition. In this step, base abstract the alpha proton and converts the carbonyl compound to enolate ion. There are 2 reactants for the Robinson annulation reaction. One is the ketone and the other reactant for Robinson annulation reaction is alpha beta unsaturated ketone. Simple ketone act as a Michael donor and alpha beta unsaturated ketone act as a Michael acceptor. So this is the simple ketone. It have to act as a Michael donor. Base abstract the acidic proton and convert the carbonyl compound to enolate ion. The question is why the alpha proton are acidic. Alpha protons are attached with the alpha carbon and the alpha carbon is singly bonded with carbonyl group. This carbonyl group have electron with the drawing ability. So it is electron with the drawing group and have electron with the drawing inductive effect, or we can say it have a negative I effect. It withdraw electron density from alpha carbon and make the alpha hydrogen acidic in nature. That's why this alpha hydrogen is easily abstracted by the base. When base abstract the proton, then carbonyl compound, here in this case, here it is a ketone, is converted to the enolate ion. This enolate is in equilibrium with its unenolized form. This enolate, which is obtained from ketone, act as a Michael donor, or we can say enolate ion act as a nucleophile. It is added to the beta carbon of alpha beta unsaturated ketone. This red colored compound is alpha beta unsaturated ketone. Its beta carbon is more electrophilic than the carbonyl carbon. So the Michael donor attack at the beta carbon and convert the compound into another enolate form. See this one. The oxygen of alpha beta unsaturated carbonyl compound carrying a negative charge. So this enolate acting as a Michael donor, and this conjugated carbonyl compound is acting as a Michael acceptor, and this is another enolate ion. This enolate ion picks a proton from the base and release the base to catalyze another reaction. The product of the Michael addition step is a 1,5-diketone. See this one, this is 1,5-diketone, and this is Michael adduct. This is Michael adduct. Second step of Robinson annulation reaction is an Aldol reaction. Intramolecular Aldol reaction occurs in Robinson annulation reaction. The product of Michael addition reaction is Michael adduct, and it is 1,5-diketone. This product contains two carbonyl group. The relationship between two carbonyl group is the 1,5 relationship. One part of this molecule will act as a donor, and the other part will act as acceptor. Here the enolate will be added to the carbonyl carbon. The carbonyl carbon is the electrophilic center. So the difference between Michael addition and the Aldol reaction is that the first step of the both reaction is the same. It is the formation of the enolate. See in the previous slide, the ketone is converted to the enolate in the presence of base, and here again the same step is repeating and the ketone is converted to the enolate ion. And the next step is the different in both reaction. In the Michael addition, the enolate is added across the double bond of alpha beta unsaturated carbonyl compound. But here in the Aldol reaction, the enolate is attacking at the carbonyl carbon. There is no alpha beta unsaturated carbonyl carbon. The enolate in Aldol reaction is not attacking at a beta carbon, but it will attack at the carbonyl carbon and gives the product will be the hydroxy ketone. The product will be the hydroxy ketone. See over here. This is 1,5-diketone. The base abstract the acidic proton from the alpha carbon from that alpha carbon which is less hindered, which is less sterically hindered, and converts the carbonyl carbon into the enolate ion. See this one, this is enolate ion. This alpha carbon is less hindered, so this alpha proton is easily abstracted by a base, and on the other hand the alpha carbon near to the blue carbonyl carbon is more hindered because it is attached with the two alkyl groups. So this enolate can be written in this way. This anion, negatively charged oxygen, is brought closer to the carbonyl carbon to make the attack at carbonyl center feasible. What happened? The enolate attack at the carbonyl carbon and gives us this oxyanion. This oxyanion picks up a proton from the base and releasing a base to catalyze another reaction, to catalyze another Aldol reaction, and the product of Aldol reaction is the hydroxy ketone, or we can say it is a beta hydroxy ketone. See this carbonyl carbon, this is alpha carbon, this is beta carbon. We can say this is beta hydroxy ketone, or we can say beta hydroxy ketone. So what is the difference between Michael addition and Aldol reaction? The first difference, the enolate in Michael addition attacks at a beta carbon of alpha beta unsaturated carbonyl compound, but here the enolate attacks at the carbonyl carbon. And the other difference, the product of the Michael addition is 1,5-diketone, but here in the Aldol reaction the product is beta hydroxy ketone. The third step is a dehydration. Base abstract the alpha proton, which is again acidic in nature because it is attached with the alpha carbon, and the alpha carbon is acidic because its electron is withdrawn by the nearby carbonyl carbon. So when the base abstracts the acidic proton, then the bond, the negative charge, the electron pair present between carbon and hydrogen move toward the carbon and carbon and pushes the OH to leave as a leaving group. As a result, water is lost and a pi bond is created between two carbon atoms. The product of the dehydration after releasing a water molecule is alpha beta unsaturated carbonyl compound, and we can say this is the product have a cyclohexenone ring system. See this one, this is a cyclohexenone ring system. We can say the product of Robinson annulation reaction is a alpha beta cyclic unsaturated carbonyl compound, or we can say the product have a cyclohexenone ring system. General mechanism of Robinson annulation reaction. We can say mechanism of Robinson annulation on a single page. One of the reactant of Robinson annulation reaction is a ketone. It is converted to enolate in the presence of base. Base abstracts the alpha proton and the resulting enolate is in equilibrium with its unenolized form. This enolate is added to the alpha beta unsaturated carbonyl compound. This addition of enolate to the beta carbon of alpha beta unsaturated carbonyl compound is called Michael addition. As a result, a new enolate is obtained. This enolate picks a proton from a base, and by releasing a base which will be available to catalyze another reaction and gives the product 1,5-diketone. We can say this is a Michael adduct. The product of Michael addition is a Michael adduct. Michael adduct is subjected to intramolecular Aldol reaction. Base picks a proton, that is also the alpha proton, and the 1,5-dicarbonyl compound is converted to the enolate ion. One part of this molecule, that is the enolate part, will act as a donor, or we can say it acts as a nucleophile, and the other part that consists of the carbonyl part, which contain a carbonyl carbon, will act as electrophilic center. So the nucleophilic part of the molecule will attack at the electrophilic center of the other part of the same molecule, and it gives us oxyanion. See this one, this is oxyanion. So this reaction is occurring between two parts of a same molecule. That's why this reaction is called intramolecular Aldol reaction. This oxyanion picks a proton from a base and converted to the beta hydroxyketone, or simple we can say hydroxyketone. The reaction of 1,5-diketone to beta hydroxyketone is called intramolecular Aldol reaction, and the last step is the dehydration step, in this step alpha proton is abstracted by a base which push the hydroxyl group to leave. As a result, a molecule of water is removed and the product is alpha beta unsaturated carbonyl compound. So we can say acyclic alpha beta unsaturated carbonyl compound is converted to the cyclic alpha beta unsaturated carbonyl compound in the presence of base. So we can say the product of Robinson annulation reaction must contain cyclohexenone ring system. If both of the reactants are acyclic, then product contain just one cyclohexenone ring system. If any of the reactant of Robinson annulation reaction consists of a cyclic system, then the product contain more than one cyclic system. But remember, the cyclohexenone ring must be the part of the product of Robinson annulation reaction. Example, I will suggest you to write the mechanism of this reaction by your own, and that practice gives you a perfection to understanding of Robinson annulation reaction. This is the example. Cyclohexanone. One of the reactant of Robinson annulation reaction is a cyclic ketone, that is cyclohexanone, and the other is alpha beta unsaturated carbonyl compound. We can say that is acyclic conjugated ketone. See, one of the reactant of Robinson annulation reaction consists of a cyclic system. So the product will contain two cyclic rings. One cyclic ring must be the cyclohexanone ring system, and the other ring system came from one of the reactant, that is cyclic ketone. The reaction is catalyzed by a base, that is sodium amide. This sodium amide will abstract the acidic proton from the alpha carbon and convert it into enolate. This enolate is added to the beta carbon of acyclic conjugated ketone and gives us 1,5-dicarbonyl compound. That 1,5-dicarbonyl compound shows intramolecular aldol reaction and gives us beta hydroxyketone. Beta hydroxyketone upon dehydration gives us bicyclic enones. This is the best example which describes the Robinson annulation reaction. This reaction occurs at 0 degree centigrade. This is another example. See here, the two reactants of the Robinson annulation reaction consists of a cyclic system. Cyclic ketone, we can say it's an enolate of the cyclic ketone, and this is cyclic enone, that is alpha beta unsaturated ketone. Both reactants consist of cyclic system. So each of the reactant consists of a cyclic ring. So the product will contain an extra ring, that will be the cyclohexanone ring instead of these two rings. See the product consists of three rings. The central ring is a cyclohexanone type ring. So the presence of cyclohexanone ring is a clue that this product is formed through Robinson annulation reaction, and we can say it's a polycyclic fused enones. This reaction is catalyzed by a base, and after acidic workup, the cyclic ketone is added across the cyclic enone to give a 1,5-dicarbonyl compound. That 1,5-dicarbonyl compound will be converted to beta hydroxyketone. Through intramolecular aldol reaction, and that beta hydroxyketone after dehydration will be converted to the cyclohexanone ring system. This is assignment. You have to write the mechanism of this reaction. You have to write the mechanism of this reaction in different steps. The steps of the Robinson annulation reaction. There are three steps. One is the Michael addition, the other one is the intramolecular aldol reaction, and the third one is the dehydration. Thank you so much.